So my talk will be again about server-side JavaScript, but in contrast, I guess, to most of the other talks, I'm not talking about Node.js. But first, a little bit of background myself. So I'm Chief Software Architect at Demandware. It was a while ago a little startup. Now we're 150 people. And what we're doing, we are offering online e-commerce in a software-as-a-service way. So our customers don't have to buy servers, run servers, host servers somewhere. They just have a login. They log in, they can put up their products, put up the prices, run promotions. An important thing is they can customize the website. And it's not that they only can change the color and the icons. They can do full-fledged customization to really implement their brand identity. Here, for example, some examples. For example, the London Olympics, the 2012. They use our system, and for example, this site is done with server-side JavaScript, pulling in, running the search, and everything. Another example is here, Crocs. So maybe some of you are wearing these plastic shoes currently. They're customers of us. Total different experience. Then here is its Burton snowboard. So if you're a snowboarding fan, you can go to the website. You can buy snowboards there. Or here, one of the Gucci brands. I have to bring it up because actually Serverside implemented that store. Then for everyone here in Germany, Neckermann runs on our platform. The whole online traffic, what they're doing is running through the platform, what I will describe over the next minutes. And last example, S. Oliver, they have also known here in Germany, and they also, for example, have a mobile site. So all you see, it's not a cookie-cutter customization, and that's the question will come later, is where we then use the server-side JavaScript. Just to give you one number, is overall we currently deliver roughly in an average day 40 million pages, and all these pages are basically rendered with a server-side JavaScript. Okay, some of them are rendered, but a lot of them are cached, but a lot of them are really rendered. That's also why I called this the untold story, because we're doing this basically a little bit in a secret. So even so now, server-side JavaScript gets a little bit popularity. Actually, we're doing this quite for a while. And we're doing this in a software-as-a-service environment. That's also what I want to like to talk about, what it really means, the constraints in a server-side, in a software-as-a-service environment, what constraints are there, and what we have to acknowledge. So a little bit about the history. So everything started back actually in 2004. That's where we actually were founded as a company. And what we did, we started with an existing e-commerce system, which was a classical on-premise software. And we said we want to bring this into a software service environment. So before, customization was done with full-fledged Java programming. And we wanted to find a way, how can we bring a customization concept on top of it so that people can configure the business logic and implement their own storefronts. And also we wanted to do things like how can we do background processing of jobs, how we can do integration into backend systems, so transferring data, how can we do web service calls, so basically everything what you typically have when you want to customize on the server. So at that time, it was clear we want to have a separate programming language. We don't want to open up Java. Java, you can do just too much things in the wrong way. We have to run that thing. We have to guarantee service level agreements. So it was clear that we want to put a specific customization language on top. So the requirements what we had was, first of all, we were a small team, and we wanted to use something out of the box. We wanted to use a known language. Wanted to use definitely something open source so that we can debug it, that we can fix it. It was also that we wanted to have a good control of the execution. That's also one reason why we said it should be an interpreted language so that we can interfere and better integrate and intercept the execution. And also because we had an existing large Java system, we wanted to have something which fits very well in the Java environment. Options at that time, clearly JavaScript with Rhino had a good stable code base, is used in a lot of projects, so we had fairly good confidence in going that approach. Options would have been JPython, project was not very active at that time. Quercus, I was actually not aware, it's a PHP interpreter in Java, I was not aware of that project at that time. Groovy was pretty coming up at that time, but it was not finished yet, so it was unclear how popular it would be. That would have been another option. And actually at that time there existed even a Java interpreter, but that was a little bit, I was skeptical about it. So that's why we choose and JavaScript, and as a coincidence, when you think about 2005, that's also where basically the whole Ajax started, and where basically JavaScript moved actually from this little dirty language to really a fully accepted language again in the Ajax. So it was a good timing that we also said, okay, let's pick up JavaScript at that time. So with that one, we did a 1.0 release, and we tried to be not a full programming environment and just a little bit of customization and everything. So my only comment was on this, flush it away, not worth to talk about it. And then we came up to the 2.0 release, and that's what we're basically using since 2006, what we have basically in our product. What you here see is just a little snippet out of our reference application. So our reference application is where we showcase a storefront. Here's a little bit thing where you can see how we have a customer. We get to the customer's profile, to the address book. Then we can get out of the address book. We can get an address, or a product list is here used, for example, as a gift registry. We can here then take an address out of the address book and set it as a default shipping address. So that's something where how you do then customization of the business logic on the server. So now I want to go a little bit more in interesting parts or let's talk about the API capability. So first of all, it's clear you have all the business objects available. You have products, you have a catalog, you have a basket, order, profile. You can call methods on these things. You can run, for example, your product searches. You have there's a search model. You just specify your parameters, and then you do a search. We also need for integration, we need data processing capabilities. So what we're using, the E4X standard, which Rhino supports, we're using that heavily so that customers can import data with it and export data and process the XML data. For communication, we have web service. They have a little bit more details about it. You can make HTTP calls, FTP calls, SFTP calls, so that people can integrate their backend systems. Web tier, we have a form framework, URL generation. We do clickstream tracking. That's all in a web tier. And then also custom business objects. And that's maybe something where I quickly go a little bit more details is, so one thing what you maybe don't see here, you don't see SQL. So there's a good reason why we don't provide SQL access, because we are in a software as a service environment. We want to change the infrastructure. When we want to decide that we go to a different database technology, we want to do it without interfering with our customers, so we are completely abstracting this one. So that's why there's no SQL here on the list. Instead, what we provide are mechanisms then that customers can model their little business objects and say this should go into the database, and we manage everything. Other things you won't find here is file system access. We have a little bit something in that direction, but it's also something which can be problematic. You don't find that you can start processes or also do something in threading. It's really meant that we provide the big building blocks, and what the customer should do is really just arrange these things. And it's also, when we look a little bit at the audience, we don't want to force all, because usually our customers are implementing these storefronts, or external partners implementing this one, and not we are implementing these storefronts. We want to have that, let's call it average developer can use it, and there's not the deep knowledge necessary on how to run a well-behaving and well-performing server-side application. So what we're using, very few words towards Rhino. So Rhino is actually the core JavaScript is very, very stable. So really in the core we found one bug once in the optimizer, but beside that one actually the Rhino core is very, very stable. Who has ever looked into the Rhino code? Or who has dealt with Rhino ever? Who has looked into the code? Who would say that it's a clean code? Yeah, that's also what we found out. This makes it a little bit tougher to debug it, but it's really working very, very stable. We have sometimes a little bit hiccups. For example, with the latest upgrade, they changed the parser did change. So because we have so many customers using it outside, we can basically say that one of our customers is actually using one of all the possible code patterns, and so they run into something where a little change in the parser caused a little bit of hiccup. And also something when you call into Java methods, because that's basically what we're doing all the time, calling into our Java system. When you have variable arguments, they change something, they look up algorithms. So this is details when you're really having basically so many customers outside and using your system and you want to keep the compatibility. That's the little issues which you can also run into. So talking about the stability XML support, we're using it. It works actually. It's a little bit in the edge cases. There are a little bit issues. So that's something just to know. We made a few little extensions or little tricks, and I want to talk about, pick two out of them. The first thing is we allow people to add a little type annotation, and the only reason we did this actually is so that we can provide in an editor good completion support. So we were back and forth, and when we gave it the first customers and our own developers, they said, no, I need completion, I cannot work with this typeless language. And so we decided to add this one. This is actually not checked at runtime, so you don't have to do it. Your program works fine. Your program works as it would be a typeless. And it's just a hint for the editor to provide the completion. Again, this was back in 2006. Nowadays, we have way better JavaScript editors who do path analysis. And that's currently also what we are looking a little bit, whether we can switch over to this one. Based on the notation, you can see it's also a little trap we ran into. It's actually the notation which was initially proposed with the ECMA 4 proposal. So at that time, 2006, we were enthusiastic that will be coming, and ActionScript already is doing it. So we put it in, and later it showed it was a mistake to do it in that way. But that basically helps a little bit to write with these fairly complex APIs to write quicker the stable code. So the other extension, I talked already a little bit about web services. And when you know web services, maybe on the Java side, you check your WSDL file, you have to put it in your AND, or for example, that the WSDL file is compiled down, for example, with access down into Java. And we didn't want to go that way, and we really wanted to fully leverage that we have really a dynamic environment. And what we're actually doing is basically the only thing what you have to do within our environment, you take the WSDL file, upload it to our servers, and then we figure out everything by ourselves and then checked it basically in the API. So what you see up here, somewhere there is a global SMS, and that's a name of a WSDL file. So whenever I say web references.global SMS, or the name of the WSDL file, the system knows that I now want to talk to a web service, and I say just get default service and have my service. When there are XML structures in that WSDL, I can say just new web references.global SMS registered user. That's create my user information, add my license information. Then I get a send message object, fill it out with phone number, for example, here for sending an SMS. And then here at the bottom, you can then see that I'm calling on this service actually a send message, and that's where I call my operation in the web service. Very, very neat. I don't have to deal with the details of a SOAP standard of the WSDL file. How we're doing this internally, here's as an example, is basically we take this WSDL file, when it's called with web reference dot the WSDL file name, we check whether we have already cached. If not, we just compile the WSDL into Java, dynamically load the Java code, find the service through introspection, then create the service instance, cache it, and then we basically give the JavaScript and runtime environment and handle on these Java classes, and from there on I can just call them. Okay, we have a few other extensions. One is, for example, it's called just import script. So it's basically the little predecessor version what you have in Commons.js, the requires function. We do it a little bit more simple. That's what we, for example, added, so that you can what you typically call you can do programming in the large and structure your code. Okay. Now a little bit the specific things, what it means to be in a software as a service environment. So the software service means we have to operate the software. So we have service level agreements about how much downtime is allowed, about response times and everything, and we have to guarantee this. And we have to guarantee this even so the software stack we are operating includes custom code. And that's really is the stretch. So how much customization can I allow so that hopefully the customer cannot interfere with my service level agreements? And when I look back, I think over the last, since we started with this one, it was always a struggle how to get this right. And it basically means at the end, if there is malicious code, it can hurt us. So initially, the obvious thing we got right from the beginning, we didn't open SQL, we didn't open the threading and everything, but we still had some things wrong. So for example, we couldn't believe it that we saw once when servers were crashing with out of memory that a customer had generated a single string with 200 megabytes in the main memory. Or we found that executing one storefront script that the customer created over 100,000 JavaScript objects just hanging around in memory. Or another thing like, how do I parse XML? Oh, I read the whole file into memory, even if it's 50 megabyte, and just parse it in memory. Even so, we give the customer a streaming API that they can do it sequentially. They found another way, oh, read that whole file in. And so from this one, that's something which regularly causes some crashing servers. Luckily, the customers very often don't see it because we have multiple servers, so someone else can pick up the traffic. But it's always bad for operations people when the phone rings in the middle of the night, they have to intervene. So what we now implemented actually is a quota system so that we can control this. So that is also a little bit due to how we did it. We did it at Rhino modification so that we can now control the length of a string. We say if someone has a string with more than 1 megabyte, something must be wrong. Same way if the length of an array, or the number of properties in an object, or the number of objects actually active in an execution context. Also, we are estimating the size of the XML tree. If that's too big, then something is wrong. And with that one, we can control a little bit like really the bad behaviors. Again, what I said, we have all kinds of developers. We have very sophisticated developers, and we have not so sophisticated developer who basically just code something, is it working, and don't think beyond this. And we cannot control the skill sets of these developers, and that's why we have to put in these mechanisms. It's also interesting when I would have other engines, for example, written in C++, I would have access to memory allocation, can change that. We are in a Java environment, that's why we have to do that a little bit more on the semantic level of the JavaScript language. Another thing is, also a bad thing, is the eval function. It was already named today once eval. And for us, it's even more risky because you could write something like eval search product and you put in directly a form value. And basically, that's the same equivalent as you would do a SQL injection. It would now be called server-side JavaScript injection. And I know you can do great things with it. And if you're a sophisticated developer, you know about SQL injection. But what about the other developers? And what do you keep in mind? We are dealing with credit card data. And when we would have an incident where credit card data is exposed, it will fall back on us. So that's why we at the end decided, okay, we must turn it off just to prevent this kind of server-side script injection. Okay. Now a little bit more lessons learned. Actually, that's one thing lesson learned was when we started, I said that we were basically coming out of the Java world. And also our first customers were coming out of the Java world. We knew it basically at that time still as a little, let's say, dirty language on the websites. And this had also a little bit consequence on the API, that the API feels a little bit more to Java-centric, how the thinking model is. So when I would design something nowadays, I would more often, for example, use closures, so that I can write way more compact, more efficient code. And also another thing was that I would more use these native objects and and arrays more often. When we first came to this, looked at this JavaScript, we used to all these great collection classes in the Java API. We thought we want to have something similar, and so we're focusing on this one. And nowadays, I would go a different approach and really use much more often these arrays, copy stuff into JavaScript arrays, and expose it in that way. That's one of the really learns what I would do different today. The other thing is a little bit how we implemented that API. So basically, we had our e-commerce logic, and we decided not to plug the JavaScript code directly on this logic. What we said, we put in a thin API layer. So when you would look at our Java classes, you would see the e-commerce logic. You would see on top of it the little Java API classes, and basically the Rhino, who can directly talk to the Java classes, would talk to these API classes. At that time, we were also a little bit concerned about performance, and when you do this style, you always have the way, am I doing it in a wrapping style? So I take a business object, put it around, decorate it, and shield certain things, or am I saying I'm really doing a full copy? So if I have my product, I copy the value, give it over to the JavaScript code. So we went very often in the wrapping style, and this caused issues, so side effects. So we have to upgrade, for example, our software. When we have new features, we have to upgrade this. And it happened several times that we basically didn't touch the API, and we have fairly good test coverage on test APIs, but there were some really strange side effects. And whenever there is something changes in the business logic with a wrapping style, we risk that it basically tickets through and is visible in the JavaScript code. You can also think about that basically the problems with VRFace is very similar to a browser vendor. We have other people writing the code, running in our system. We have to keep it compatible. We have to avoid side effects. So we're basically in a fairly similar business. And that was one lesson what I took from this one. Copying is not so intensive. Copy the stuff and make sure you're basically separating and really isolating from your actual business logic. Okay, so now I want to also talk a little bit about the future. So what is in our plans? So one thing what was mentioned today already a few times is common shares. So that's what we are currently looking into it, what thoughts are coming up there. So we will adopt the module concept, so to replace what I mentioned before, what we have an import script, which is a tiny little bit awkward to replace that. We're looking into the package concept. We're looking also in the unit testing, so we currently have basic unit testing in there that you can run assertions and check assertions and everything. But maybe if this, maybe want to take this one, what's currently in discussion. Other things, what is currently proposed in the common shares is not applicable for us. It's again, because we are a software as a service environment, we cannot have streams, we cannot, or sockets, we will not have a real full-fledged file system access, we will always have the abstraction of just storing blobs. We also have no real notion of a standard in, standard out. So, so the common shares, so we will constantly look at is whether we can adopt some things, but we will not go the way that we say, okay, we will implement everything. Another thing what we will change, it's also something when we really go server-side, is when you think about the template language. So we currently have a template language in the system, which is mostly inherited from the existing old system. And yeah, it's a little bit ugly. And so we're currently looking to replace this with something which is fairly simple. And so we took some ideas maybe how the Ruby works, and so just these little smaller and % symbol, then you can insert JavaScript code, and in between it's all HTML, having some libraries that I can do just T for template utilities, link, and can generate a link, for example, to another page. So that's what we're currently thinking about doing. If someone knows about a project where someone is doing, yeah, we should talk. Yeah. Yeah, we should talk on that, and so that's also what we're currently looking around. If there's a cool project, a little bit, someone around it, so also we are happy to help there and also use it then on our side. Okay, that's actually all material what I had prepared, And any questions? Or is everyone hungry? Who's hungry? Oh. I don't know whether this is the maturity. Okay, good. Thank you.